In our final installment of our look at the computational linguistics landscape, we're talking about the kinds of contributions you can make in computational linguistics.
Talked about things like industry versus or in tandem with academia last time. And so we're going to kind of move to a different angle on describing the kinds of roles that somebody could have in computational linguistics that could be useful as you think about the kinds of things that you might like to be doing.
The way I thought we would structure this conversation is that I could list some of the models of successful contributions that people have made in the field at a high level, and then Philip might react with examples of these sorts of successes that people have had in these kinds of contributions. And we should say at the beginning that these are a bit of a caricature. It takes multiple different skill sets to succeed in computational linguistics, and in the course of a person's specific very unique career, they will take on many different roles. And this is more about what someone will be known for, i.e. the foundation of how you build up your career over time. And maybe you will transfer from one to the other and back again. And that's perfectly normal.
The case. I mean, I usually start by making a roughly three-way distinction between theoretical kinds of contributions, algorithmic, and experimental, where the theory can be about proving things, or it can involve sort of the reasoning that goes into theorizing as a backdrop for other kinds of work. When I think about algorithmic contributions, I think about coming up with algorithms, but also things like time complexity. Can I do this more efficiently? Is the stuff that I'm really interested in. And then when I think about experimental, that's the applications-oriented work, or in science, trying to come up with ways of understanding and explaining things in the world.
Let's start with the theoretical side, as you mentioned. To be clear, there are subtypes of this person in computer science and linguistics. We're trying to be fairly broad here. The caricature is of a person who sits in their armchair, thinks really hard about something, writes a beautiful paper about the underlying theory in linguistics or an algorithm that can solve the problem. But that isn't always the case. There is often some experimentation or data involved in even highly theoretical analyses. But the distinction is that the contribution is the idea rather than the implementation. For these sorts of research papers, you read the paper, the code and or data are secondary to the idea.
About theory, in my mind, I tend to directly connect that to the idea of science as opposed to engineering per se. Right? So, and science can include two different sides. One is the science of natural phenomena, trying to explain things in the world, the cognitive science side of computational linguistics being a clear example. Or, this quote, when Fillmore is talking about linguistics, he is thinking of linguistics as a science. But there is also what Herbert Simon in the late 1950s called the sciences of the artificial, where you can have human-made artifacts, road systems, farms, and these days, deep learning architectures, where some of the science and the theory behind the science has to be about trying to understand what these artifacts are. And when you think about theory, it's also useful to distinguish what David Marr described as three different levels of explanation. One of which is the computational, what he called the computational level, which is a formalization of the problem or the phenomenon that you're describing. A central level that is the algorithmic or representational level, which has a more process and representation oriented feel. And then at the lowest level, in some sense, you have the implementation level, whether that is in silicon or in wetware. And I actually think that way of looking at levels is a useful way to inform how one thinks about the theorist's possible kinds of contributions.
Okay, so moving on to archetype number 2, the problem definer. This is a role that I like to imagine for myself. There's an adage in research that you should either be the first to work on a problem or the best to work on a problem. And I'm not skilled enough to be the best, so I try to work on new things, define a task, get people interested in the problem. This could be trying to get machines to do something new. Let's try to detect someone's sentiment, trying to do an old task with a new framework, use reinforcement learning algorithms and rewards to measure simultaneous translation, or via new evaluation, measure the interpretability of machine learning algorithms rather than just looking at their accuracy.
Or maybe it's better to say that's the way that I have tended to find myself, to the extent that I've done things that are worthy of notice in computational linguistics. They tend to be the cases where somebody goes, duh, right? But somebody else didn't do it first, right? I am not going to be the person who is going to crank performance up from 92.1% to 92.7% on something. I'm hopefully going to be the person who suggests this is a thing that one can do, and this might be worth doing, and then other people who are way smarter than me on those dimensions can go and figure out better ways to do it.
So let's talk about those smarter people. The problem solver. In contrast to before, where you might be the person who sets up a leaderboard, the problem solver is the person whose name is always at the top of that leaderboard. No matter what the problem, you can squeeze a couple more F1 points out of the implementation by tuning parameters, refining the model, inspecting the data. A lot of the papers you see are of this type. People hack away at an established problem, making slight tweaks to existing models to improve the results, and these are really valuable. You talked about tech transfer in the previous video. If you want to have a successful implementation of a tool, every little bit that you can improve the results often improves a company's bottom line, and so the people who can do this reliably are really valuable.
Thing you said, except possibly the terminology of problem solver. Leaderboards are not about problems. Leaderboards are about tasks. You have problems, and then you abstract them or formalize with a particular data set, an evaluation measure, a definition of what the input and output are going to look like. Those things are tasks, and tasks are not problems. So if you can do a good job of mapping a real-world problem to a task, then the task improvers, if you will, right, the performance improvers can focus on that, and there is an enormous value in getting there. But I would distinguish that from the bridging role that is necessary in understanding what the problem is and how to translate that into a task. In an ideal world, the problem solvers and the performance improvers would actually, more often than they are now, be the same people. And right now, there is such an emphasis in the field on, scare quotes, tasks and SOTA chasing, state of the art, got to be better than the state of the art, as defined by the tasks, that I think a lot of people, particularly people more senior in the field, feel as if, to some extent, we've lost sight of the notion of the problem as opposed to the notion of the task.
Agreed. So moving on to the next archetype, this is a bit of a fine distinction from the problem definer. A definer is someone who creates a totally new task that's obviously within the umbrella of computational linguistics. And what I'm trying to put forward here as a boundary pusher is someone who takes existing ideas and adds them into what we consider computational linguistics. Often this is by taking a technique, a model, or a problem that is already known and has convinced other people in some other field that it should be studied, but that hasn't happened yet in computational linguistics. One way to do this is to add to the list of languages for which we commonly do natural language processing, or to make us think about statistical significance more rigorously, or tackling ethical or societal problems. The problems always existed, but there wasn't agreement that they should be part of computational linguistics.
I think that this category is a place where you can really highlight the opportunities that computational linguistics has as part of a multidisciplinary enterprise. I think that what good boundary redefiners do often is recognize that there is a connection between some particular problem space that they've been looking at in language and either a set of approaches, right? You mentioned here Gibbs sampling, or a set of domains that people have not focused on up to this point. And the rise of computational social science, for example, is, in my book, one of the places where you've seen a lot of the contributions where people have been trying to and often succeeding in crossing boundaries, at least in part because so much of the data that one cares about in computational social science takes the form of language.
Exactly. Let's talk a little bit more about the data. Another way that you can make a contribution is to help people get the data that they need to do their research. This overlaps perhaps a little bit with the problem maker. As to define a new task, you often need to get new data. But you don't necessarily need to do a very good job of it or to get a huge amount of data. There's a special kind of researcher who can lead an annotation effort of dozens of annotators over years to create an entirely new tree bank that turns a linguistic theory into something that people can actually work with computationally.
Absolutely right. Why don't you give a couple of examples?
Two examples that come to mind are Feifei Li at Princeton and Martha Palmer at Colorado. I saw Feifei put together ImageNet. I was very much on the sidelines. They were dealing with so much data that they had to put together special computers. They were paying annotators so much money that they had to get special tax consultants. It really was an undertaking, and ImageNet is what it is because of that amount of effort. And while I was at Colorado, I saw the infrastructure that Martha built around a stable of annotators who can make subtle distinctions about really tricky linguistic judgments at scale with high throughput. In many ways, it's like a utility. You don't think about all of the work that goes into it because it's always been there for you, but your life would be miserable if you didn't have it.
Entire organizations devoted to this, the Linguistic Data Consortium, or LDC, being a great example where there have been very general resources that are produced, but also, going back to what we said earlier, when there might be a particular funding project of some kind that requires resources, doing more specialized work to support that. And the researchers that you mentioned aren't just resource builders per se. They are researchers in the broader sense, and an important segment of what they're doing is in understanding the phenomena, the constructs that you need, and then as part of what they're doing, contributing these resources to the general community. I think about the folks at NIST, the National Institutes of Standards and Technology, in a similar way, because the ability to evaluate things effectively, which is a big part of what the language-oriented folks there spend their time on, that ability to evaluate effectively is also really central to research projects. So I would put that in with this general space of resource creators as well. And the last thing that I would say is the pendulum swings back and forth. It used to be, we thought of resources, we didn't think in terms of resources in this way. We used to think in terms of, well, you're going to build rule-based systems or knowledge bases of some kind as resources. Then the supervised learning era came where we realized you could put knowledge into a system by annotating. And then you moved heavier into the, we're going to learn everything. We're going to do machine translation starting from pixels. Right? The pendulum swings back and forth. However, I don't think we are ever going to see a world in which there is pure self-supervision. All you have are things out there behaving in the world. If nothing else, you're going to have resources that provide some form of inductive bias that comes from the heads of people who have actually studied a particular area and figured out ways that could be important when you're building a system.
And even as the pendulum might move back to more unsupervised techniques, this is still going to be important because even when you're talking about quote-unquote unsupervised data, the quality of the data still matters, and you need to protect people's privacy, you need to make sure that the data are balanced, and so even in unsupervised domains, people who can put together high-quality resources are still indispensable.
This is one of the primary loci, if you will, the primary locations where you have to think carefully about ethical issues and bias. Right? In terms of data resources, you need to think about where you're sampling from, who has gotten to participate, in effect, in contributing to the things that you are learning from. What are the privacy issues that might be there in the data that you're creating? Right? In terms of knowledge resources that are going to be there for a really long time, right? How are those possibly biased or balanced in terms of the influence that they're going to have on the system? So I think this notion of resources is a really nice anchor point, a starting point for thinking about a place where the ethical issues are really clear. And some of the work that's gone on in ethics in natural language processing has really started from this point. So for example, the data sheets for data sets paper, right, is a really good example where if you're going to have data sets, here are things that one should be thinking of when you are considering the possible ethical implications of what you're doing. The model cards work has a similar flavor.
Let's move on to archetype 6, where the question of what to work on and how to work on it becomes a little bit more clear. Here we're moving away from roles defined entirely by research projects, but these are clearly indispensable to the research endeavor. Research would not happen without leaders, and for some big projects, you can't succeed without bringing together a resource creator, a problem solver, and a problem definer. But getting a bunch of self-absorbed researchers with their own agendas to work together can be a huge challenge. It takes special researchers to organize such a team, make progress on the problem, and turn that into something that the rest of the community can learn from.
Earlier, I talked about the relationship, say, between startups and the academic research enterprise. I think startups and industry are actually a really interesting model for thinking about that. I took a management course or two when I worked at Sun Microsystems Labs. Product development methodology. It was actually a very early version of what evolved into Agile, actually. Being able to listen to people and so forth. And I have to say, that experience has been, and the startup experience as well, has been one of the most valuable things in the academic research side of what I do. And I think there are some people out there who are great exemplars. One that comes to mind is Chris Manning at Stanford, who is a superb researcher in many of these other categories, but he's also been an enormous leader when it comes to building and managing a group that is producing a steady stream of contributions to the community as a whole, and doing so in a way where these things all play together. It's not just managing, a set of things working in silos, but figuring out how to make these things be something you can look at almost as a unified whole.
Stanford is a great example because part of Chris Manning's leadership was producing software artifacts, the Stanford NLP pipeline, that people used for all sorts of research for just about every aspect of natural language processing. And this brings us to archetype 7, which is about building the infrastructure for others to do research. And even though it's crucial, it remains underappreciated and overlooked, in my opinion. Building data repositories, toolkits, or communities is hard. Sustaining them for decades is even harder. But these are the sine qua non of research. Without WordNet, NLTK, WIML, PyTorch, Hugging Face, or Black and AI, many research projects would not exist, and many researchers wouldn't be able to thrive in our community. And the connections that a leader needs to form a team just wouldn't be there.
Now, there's another category of facilitators to think about as well. And those are the people who provide the human infrastructure, if you will, not just the technical resources and technical infrastructure that are used by the community. That includes the funders, right? The National Science Foundation, the program officers, the review process, the people who volunteer to be on peer review panels for NSF and NIH, DARPA, IARPA. Those are enormously important facilitators, not just providing money, but providing infrastructure, including not only the gatekeeping, but also creating an environment within which researchers connect with each other. And you see, again, this idea of bridges or connections that you might not have seen before. And then, of course, there's the entire notion of service. There are many people who are tremendous contributors in terms of the service that they perform for the community. That can mean being an officer of a professional organization. It can mean being an area chair at a conference. It can mean serving as an editor of a journal. It can mean being somebody who reviews papers or journal article submissions. The people who take their time to create tutorials at the conferences. And these days, people who take the time to create and release good tutorials that can take somebody who's new to something and walk them through how to do something that's at the current state of the art. The folks who created NLTK and have a book accompanying the software resource. All of these are facilitators of the community. And finally, as you have here on the slide, this idea of mentoring is really important. The human-to-human connection is really a central part of facilitating work in the field, whether that's an advisor-advisee relationship, a mentoring relationship, a meetup, and so forth. And to go back to underrepresentation for a second, that notion of the human-to-human connection, forget about all of the bigger systemic things that we can do. That human-to-human connection is a place where we as individual researchers can contribute, right? By spending time focusing on making other people more visible, helping forward them in their ability to move their career forward in the field. And so, but in many respects, this idea of facilitating the community, it may in fact be the most important way that people can contribute.
I totally agree, and that brings our conversation full circle, where we began talking about what the community is, and we end by talking about how people make that possible. So that's a great way to wrap this up. Thank you, Philip, for helping contribute to this discussion about what it means to be a computational linguist, where you can make contributions, and where you can get a job. I'm sure we left out several important topics, so please, if you think of something we left out, leave a comment below to help us do better next time. But hopefully this got you thinking about the ways that you can leave your mark on research and to help us better understand natural language processing. Thank you again, Philip, so much for helping to discuss the different ways people can contribute and participate in computation. If you want to see more videos like this, check the video description for the course that comes from the link down below. You can then see the context and the correct order for watching these videos. YouTube will gleefully show you stuff in the wrong order. If you want other people to see this video, provide a big gradient to the recommendation algorithm by clicking the like and subscribe button down below.